Good evening, everyone. Excuse me. My name is Paul Thomas, and Alex and I will be presenting on behalf of Team Stantec. I would like to begin by again thanking the City of Chattanooga and all the sponsors for hosting this competition. Our team was comprised of 2 civil engineers, 1 transportation engineer, 1 landscape architect, 1 landscape designer, 1 marketing specialist, and 2 students, one of which will be presenting with me this evening. To begin the project, we needed to define the extent of the project area. Our intent was to reduce the amount of stormwater entering the city's combined sewer system. We assumed that the storm sewer along Broad Street discharged to the city's combined sewer system. We also assumed that some portion of the side drains adjoining properties, both east and west of Broad Street, discharged to the combined sewer system along Broad Street. For that reason, we elected to extend our project area outside of the right-of-way to include half of the city block, both east and west of Broad Street, and to design a system that could manage this defined surface area. This project area, coupled with 1-inch capture requirement, was used to calculate the project's target stay-on volume. In short, as opposed to treating solely Broad Street, we wanted to be prepared to retain all the stormwater that could flow to Broad Street. Alex?
Hi, I'm Alex Eversbush. I'm a student in the Landscape Architecture program at the University of Georgia, interning with Stantec's Duluth, Georgia location this summer. I'll begin by talking about our process. Our process began by re-envisioning Broad Street as a whole. We chose to adopt a curveless system as well as remove the median in favor of a more open and accommodating system to all types of vehicular traffic, and pedestrian traffic and bike traffic, as well as many stormwater management techniques that we considered. We then summed up our idea of stormwater management in 3 main ideas and divided our site into 3 zones, one to feature each of our 3 big ideas: restore, recharge, and retain. This is a typical cross-section of the way we decided to break up the street. Travel lanes in the middle, reverse angle parking going towards the outside, protected bike lane, our stormwater management feature, and pedestrian sidewalks on the side. Our master plan reflects the division of this site into the 3 main zones. It should be noted that we chose to incorporate permeable paving into the entire site on all of our reverse angle parking, setting the stage for a comprehensive approach to stormwater management. Our first 2-block zone runs from Aquarium Way to 4th Street. The theme of this area is restore, and our goal is to return the site and surrounding watershed as close to its original hydrological conditions as possible. In this section, our stormwater management technique of choice is a series of stormwater spines. This is a system of curveless voids in the pavement, which is built with high-density vegetative materials such as wild native grasses or ground covers, which have natural filtration qualities. This system filters and directs runoff to a desired infiltration point, allowing water to move in the way that the landscape originally intended it to. Our second 3-block section runs from 4th Street south to 7th Street. The theme of this area is recharge, and our goal is to return as much stormwater runoff back to the water table as possible. In this section, our stormwater management technique of choice is a series of biofiltration swales. Biofiltration swales allow the runoff to infiltrate the footprint of the swale after passing through highly dense vegetative material, allowing for an ecologically conscious recharging of the watershed and water table. Our final 3rd and 2-block zone runs from 7th Street south to MLK. The theme of this area is retain. Our goal here is to capture as much of our excess runoff as possible and avoid discarding what can be reused later for the benefit of the city. One possible reuse could address odors on Broad Street by flushing the combined sewer during drier times of the year. In this section, our stormwater management technique of choice is a series of modernized aqueducts. Our modern aqueduct system is similar to a system of flow-through planters, which are also full of highly dense vegetative material. And this allows the city to filter and direct the excess runoff into underground cisterns for future reuse. Our hope in this design is to create an educational and beautiful area. We want to accommodate pedestrians, bicyclists, motorists. Most of all, we want to improve the quality of life in this area. And with that, I'll hand it back over to my colleague, Paul Thomas. Thank you.
In summary, we feel that our design was a success. From a financial standpoint, we were able to provide the city with an additional 65 metered parking spaces. This not only benefits the city in the form of an increase in revenue, but also benefits the community. Our design also reduced the amount of stormwater that would be discharged to the combined sewer system, resulting in a net savings to the city. This additional revenue and savings would help to offset the additional costs required to construct the Green Street Improvement Alternative. Lastly, by widening the extent of the project area, we feel that we maximize the green infrastructure concept. Over time, it is expected that adjacent property owners will begin to install various stormwater management practices in the form of green roofs and reuse programs, which will continue to make this Broad Street design more and more conservative with time. Thank you very much.